Intros. I am Nicholas. I am the president. I know some stuff. I don't know much stuff. Moving over to...
I'm John, the vice president. Everything. Ask me questions. DM me.
I'm Trent. I'm the social chair. I know nothing.
I'm David. I'm the CTF chair. I do a lot of CTF stuff, so I don't know. That's probably my knowledge base.
I'm Isabel. I'm the secretary. I have no idea what I do, but I do stuff.
All right. Okay, so cabinet. If I miss something, if you think I'm less than clear, point it out, because this is just going to be a live attempt at doing this.
Feel free to ask.
Yes.
I was going to say, interrupt this man. He knows nothing about what he's talking about, so he's probably making no sense to you. Just
Yeah.
And if he doesn't see your hand, just cut him off.
Yeah, no, shout it out. If you feel like I'm going down a rabbit hole, shout that out too, and I can move on to the next thing, because I sometimes get latched on stuff, and then we spend 5 hours working on a really obscure random thing that no one cares about. So, first thing, looking at the CDC, we're going to go over to the scenario document. This is where we get the fun scenario of we're the IT department of corporate dime counters. A lot of slightly cringy stuff. Basically, this is going to be a bank. Our job is to secure it. It's probably crap security. It's crap security. So the next thing we're going to want is we're going to take a quick skim through of what servers we have that we're going to have to work with. The big things is looking at the operating system, in my opinion. So first skim through, we got a Windows, we got an Ubuntu, which is Linux, pretty standard one if you're unfamiliar with it. Another Ubuntu, an Alpine, I've never worked with that, probably a Linux. A Windows Server 2022, never heard of that, it's 2021. I'm going to guess it's a 2012 server because that's when servers come out and typos are a thing. So that's all of it. So we have 5 different systems we're going to work our way through. And then we get to look through the required access. Rather than going through all of them, I'm just going to go to the API server because that's what we're actually going to be looking at. So we have to have access on port 22 for SSH. Normally that's relatively secure if it's all up to date and your attackers don't know your passwords. However, we have to have an HTTP access on port 80 and 443. It's an API, so it's probably actually doing stuff to the computer. So this is probably where most of our security problems are, just because that's...
Hey, Nicholas.
Yeah.
What's an API?
Application something interface.
Programming interface.
Application programming interface. It's a set way for different things to interact with each other. So this is probably where we're worried about. We also see that red flag. So flags are how you lose points. You start off with all of the points and then you can lose them basically. If red team gets access and puts their red team was here.txt at this location in your directory, you lose points. And then you're going to put, for blue flags, my super secret code in root. And if red team gets to turn in your super secret code, you lose points. So those are kind of the things we're trying to protect. So we're going to go over to vcenter.iceage.org right here. And then log in with your username at iceage.org and then your password. So I'm going to wait like 10 seconds. I hear a very little typing, so I'm assuming everyone's either there or not following along, or they're locked out because of password requirements. I prefer to use the launching remote console here. I think it's better. It should let you copy and paste stuff. It doesn't work for me ever. So I launched the web console, which opens up a tab like this, and we get a command line interface for our box. You'll notice we have root at API, so we logged in as root. One of you guys on this already?
I am.
You are, okay. You'll also notice that if your teammates log into vCenter, they can type and you'll see each other work. This is going to go great if they're typing as well. So first thing that you're always going to want to do is updating your computer. If you aren't familiar with Debian and Ubuntu style computer or Linux distributions, there's a bunch of different ones. Debian and Ubuntu are the ones I normally use, and I feel like I've encountered the most. They use the Apt Package Manager. This is the program that keeps track of what version all of your software is on. So the way you check is sudo apt update. Oh boy, now I'm just terrified of making typos. Sudo apt update.
I'm pretty sure this takes a long time to like it has issues with headers or something.
Awesome.
It's not, did you set up the
I
proxy
did
yet, Nick?
connect it to the proxy.
Yeah, you did it. You got in.
Get through.
Hey.
Okay.
So talk about proxy because you're not going to be able to apt update without FTP.
Alright, it's got to
Okay, I thought I had it.
But that looks like your issue
Yeah.
right now.
Okay, so we have put up a firewall.
You're not behind it though.
We're not behind it.
Nobody's behind it. I literally just popped in the ISO.
Okay, so because we work in the ice rink, this is really funky fun stuff with, okay, you turn my stuff yellow. They have really funky stuff with how you connect to the internet. What you always want to do is sudo apt update, sudo apt upgrade. So the first one checks if there's anything that you need to update, and then the second one is going to upgrade everything. The reason you wanted to do this, software always has bugs. That's just the case. We're constantly finding bugs. We're constantly developing exploits for those bugs. If you have some service from 5 years ago, it can easily be exploited normally. So sudo apt update, sudo apt upgrade is the first thing that I always try to do just to make sure that all of the super low-hanging fruit, the stuff that's there, easy to do, is updated. This is going to be slightly problematic if I don't have internet.
Yes, it will.
Yeah. So the second thing,
You have to connect them to the internet anyway, right? So it'd be good thing
You
to
don't
run.
have to.
I thought we have so
If
much
you want to
If-
update them, you have to.
if one of you wants to do that, because I'm super iffy and I don't want to take 10 minutes as I
We've been
mess
doing
with
it.
proxy.
Me, David, and Isabel can do that in like 30 seconds.
Okay, why don't you guys do that in 30 seconds?
So I gotta log onto this box. Hold on.
Okay, so I'll explain the command that I just ran then, the debsums command. If anyone,
My bad. I was gonna start trying to connect to the internet.
go for it.
Oh, you got it? Okay.
Yeah. So, who has heard of hashes before?
Hey.
Okay, so a solid what, like 60%? Hashes are basically the idea that you take an arbitrarily large amount of data, you stuff it through a mathematical function, and it gives you a fixed length output. So imagine you have a 500-digit number. You take each digit, you add them together. If it's only one number, you do that again until you only have, and then that example. Basically, what debsums is going to do is going to calculate the hash, which would be unique and impossible to predict unless you run it for each program, and then it'll compare it with what it should be according to a database hosted by some trusted third party. The idea is someone doesn't come in and change your change password program to be a backdoor always opens or it always logs in with CDC. So you don't know if you can trust everything until you check if the stuff that is called like password change or is actually the program that you think it is. Did that make complete nonsense, or did anyone have like an gist of what I just tried to say? I'm seeing some nodding. All right. So debsums, are we good?
Yep.
Okay, so sudo apt update.
Maybe don't run sudo.
Okay.
Yeah.
Apt.
Hey, there you go.
There you go. Okay. So apt update, we're getting the list of packages, things to update, and then it doesn't give me a list of stuff.
While it's
Sudo apt
to app tech V, I think.
tag v
No, the update tag V will tell you what packages are updated. I don't know about
update.
upgradable, yeah.
Okay. I'll just do this and hit no.
We'll give you.
Okay. To give you an idea of why I always write sudo when it's probably not the best option is because you shouldn't always be running as root because you can break things. There are no guardrails for root. And if you're a regular user, you type sudo, and then you can do a particular thing as root. Yeah, it's on my list.
Yeah, but that's
Yeah. So, and that deals with like the permissions on files. So, if I run sudo, I'm do stuff as root even if I'm a normal user, but however, I'm normally root right now. Apt upgrade. And there's going to be 131. Do I have a mouse? I don't have a mouse. Right here, 131 updates are available. So normally I'd run that right now, but that's going to take a while, and we don't want to watch it update. So the same thing with debsums. It'd be apt install debsums. So any package you want to add, any program you want to add, you do that. Say yes, and it downloads and installs. So, having checked that all of our programs are up to date, and they are what they claim to be with debsums, the next thing is you're going to check, you're going to want to change all your passwords. So the default passwords, as you see in the document here, is root CDC. Red team knows this. If you leave the password as CDC, you will lose every system in less than 5 seconds because they will make a script that will just auto-pwn everyone. They'll just try root CDC on all of the machines. If you change it to root DCD, you will last much longer. It does not matter what password it is, asterisk, it does not matter, asterisk, what password it is, as long as you change it to CDC. That said, do change it to something good. Because if Red Team is able to guess it, for example, if it's password 123, you will also lose very quickly. All right, so I don't go back here. The next thing that's worth looking at is what accounts exist on the computer. So the best way that I know how to do this is looking at the password file. Now this file does not actually contain passwords. It did back in the old days when security didn't matter. And you can see here, each line has the user. The top line here has root. And then their home directory right here. And then what shell they're using. So what you can do is you have a bunch of different ones that you're not going to recognize here. Like, do you actually need to have news on your system? I don't know. I've never worked with the news user before. But what you can do is you can jump here to the end, and you can see what shell they have, and it's no login. So that means they don't have a shell if they log in. So that in my mind, that has kind of made them much less of a threat. That's much less to be a backdoor that they're just going to be able to break into. Any comments? Because that's, I realize, an assumption I've made without ever getting backing up on that. Yeah, so if you have user sben no login at the back of the username. We think it's safe. Mileage may vary in the real world. So we'll go down here. We don't see anything with non. So this one's kind of interesting with no shell at all. I'm assuming that's going to be safe because that's probably roughly the same. But you're also going to have false. That's probably good. False, false, no login. And right here at the end, we have user CDC with a shell. Any guesses what that user's password is going to be? I'm going to guess CDC. I don't know, but there's a good chance. And it's not in the documentation. You'll sometimes also see that. There is no mention of a user CDC on here. So I'm going to guess that that is not a user that we want to have on our system. So Mac doesn't give me an escape button. What was the deleting? What was the deleting a user command? Do you remember?
User down.
User del CDC. So that didn't yell at me, so maybe it worked. Yeah. So now CDC is gone. One backdoor that Red Team had has now disappeared. So that is good to know. I didn't write. No, I did. Okay. So we've now checked at what all our users are, and there are no unknown users on that account. I will note, sometimes you need to have users on the box that aren't just you. You'll see that stuff in the documentation here at the end. Like you'll have different bank tellers and loan officers and IT administrators and heads of banks, and you'll see in this what they have to be able to do. For example, the IT administrators probably need to get onto this box and administer stuff. Job title. So you'll have to figure out what password they're supposed to have, which should be in, is it iScore?
Yeah.
It's in iScore team-specific info right here, which I'm not going to click on because this is going to go on YouTube, and we don't need Red Team saying what my team-specific information is.
I think I got that one.
Don't leak your shit.
Yeah, don't accidentally give Red Team stuff they don't need to know. So now that we know that there are no users on the box that we don't have there, backdoors, this is common enough in industry in the case of just not getting rid of people's accounts when they're leave or fired. You can imagine that happening. I worked at a place 5 years ago. I left. They just never took away my username and password. And now I can log into their place 5 years from now. Not super great security. Next thing I have on my list, we're going to skip firewalls for now, is file permissions. So, who has heard of what file permissions are? A solid 80-90%. File permissions basically mean what you're allowed to do on the box. So if you see here, the command is ls-tech-l. Not sure what the capital F did. You'll see on this far left column here, the RWX, RWX, RWX. R stands for read, W for write, X for execute. A lot of the stuff on the system, it's kind of hard to tell exactly what it is. The farthest right is what everyone can do. If the farthest right column has RWX, everyone can read the file, write to the file, and execute the file if it's a program. And then the far left column is the user, so the person who owns that file. You'll also see in these two columns who the owner is. In this case, it is root. We are in the very top of the directory file system, so this is like where a lot of important stuff starts off. So it makes sense that root is going to control that. One file that is particularly important is the shadow file. So back when I said that passwords used to get stored in the password file, when they didn't care about security, they were just stored there in plain text. So anyone could read them. Not super great security. Now they're stored in the shadow file in a hashed format, ideally. The only person who should be able to read from the shadow file is root and the shadow group. You'll see this is actually the correct permissions. The owner here gets to read and write to the file, and the shadow group gets to read from the file. If on any of your boxes everyone can read, that means as soon as red team gets a foothold, which you have to assume they will be able to take all of your password hashes, and then they'll be able to crack them offline. Due to the way that this competition works, your administrators have pretty bad passwords. That's just to simulate if they were going to be a longer-term red team, they'd have a lot longer time to crack them rather than a couple hours. So they shorten the complexity and they tell you what they have to be, and they're pretty bad. So if they get the hashes, they will be able to crack them. So you do not want that to be the case. So in this case, we're lucky. It is set up correctly. You good?
I was gonna just show them the shadow file, but
Oh yeah, no, we can show them the shadow file.
well, it was supposed to be dumb, something dumb I could do.
Yeah.
A lot of dumb stuff.
Is that shadow or password?
That shadow, that doesn't look right.
Oh, no, yeah, it's good.
Oh yeah.
There's only one logon user.
Yeah, so what was confusing me, most of the stuff's supposed to look at on the top, which is you see the $sign, which says what type of hash it is, and then it's a large amount of junk, which is the hash. None of the other ones have that, which threw me for a loop for a second. So far, so good. All right.
Can you redefine shadow for a second?
So let me think here. We have, back before security was a big thing, in the password file you'd have the username, the password, other junk. And to log on, the computer would take the password you supplied it and look in the password file. Now I'm pretty sure everyone got to look into that password file. So if you logged on to the computer, you could just open up the password file and be like, well, Bob's username is Bob and his password is password. Not great. So Shadow, they couldn't change it that much because that would break backwards compatibility. So they created the Shadow file. The password file still contained all the same stuff except for the password. The password was moved to the Shadow file, had much stricter permissions put onto it, and rather than storing a plain text password, so not just regular password, it was hashed, which I terribly explained before, which is, in this case, the important part is a one-way function. If you have the hash, you can't pull the password back out of it, but if you have that password, you can generate the hash. So now what the computer will do is it'll take the password supplied, hash it, and then compare the hash with the stored hash in the password file. Did that make sense? Okay. The next thing, in this case, the biggest parts are more or less basic security done. This will probably keep you, Red Team will actually have to think now to take over this box. So now let's return to the documentation. We want to be working on the API box. SSH, that's normally secure. I haven't had any experience with SSH being the way they get in. Normally it's just a useful thing. Once you have access, like a username and password, you're able to log in through there. Not the way that they get the initial username and password. So we have this is the more problematic thing right here. So, no. Let's see, that's probably going to be in var. So that's just going to, so var is the stuff that has the variable size. What do we have here? Was there an easy way to get us to proxy in so we could view the web page?
pfSense is being annoying, and I accidentally served a bunch of DHCP on the competition network for a minute there. So we're burning it and starting over.
Okay. What is one of our Windows
It's
boxes?
usually the Windows box.
Yeah. ATM. Okay. So, because explain what just happened there. Our machines are separated from the normal internet. You can't really reach them because every less than ethical hacker out there is going to automatically scan stuff and then break it because these boxes are very vulnerable. So we put them in Ice Rink, which is something I don't fully understand yet.
I can draw a picture of it.
Which protects our stuff, so we can't easily reach it. There is a way to do proxies and whatnot, but the easiest method is just opening up one of your other machines. And let's see, did we change the password yet? CDC. Welcome. All right. So now we have a box that's on the competition network. Open up Edge and API team number dot. I'm just gonna go. Oh. Check what the password is. Does this not have a password right now? This has an IPv6 password. That's interesting. No. So if config is just something that shows you the internet configuration stuff. Interface configuration. It looks like we have 33.96.520, 33.96.5.20. So this is the box.
Try putting it on 480.
So TTP. So if anyone is unaware, URLs are just a fancy way to let your computer know what to look up to find this number. This number is actually the IP address, the unique identifier to how to get to that server. All it does is say OK. Dash docs. Cannot get docs. The IP address is how you get to the server. The URLs are just a fancy thing we slapped on top to make them easier to read for humans. So you can always just navigate to the actual IP address if you're able to know that. But, good luck actually remembering this is 33.96.520 rather than api.team, whatever it is, isocdc.com.
So much easier to remember.
So much easier to remember, for most people at the very least. So now we can poke around. Can I get etc-password? And this is where it is a little less clear cut. We've kind of gone through the step-by-step. Every box that's a Linux system is going to have these sorts of things you want to check. Now we're working on the application-specific stuff. You got any idea where the documentation for this would be? Sources. Yeah. Always read documentation, something I almost always ignore but always regret. The source code, it says here, is located in this directory.
Also looks like it's on for API 3.21 where you're trying to get web API.
So we can go in here and we have what the program does. So at this point, you're just going to want to open it up. It looks like it's listening from here. It looks like it's listening on port 3000. Do we have any Kali boxes or anything up and running?
No, I've been poking the firewall. I can spin up a Parrot.
Yeah, I just want to in-map this thing.
I
Yeah.
should do NetStat from the.
Just can you install like net tools on one of the CLI boxes?
They have. I think it has that. They all have NetStat.
So-
if you go to NetStat, check what's
What we're talking about right now is
I'll start spinning it up. But it's gonna
What?
take like 20 minutes.
they say is on is probably on. It may not be everything that is on. So looking at this line makes me think that something is listening on port 3000. So you have localhost, which means on this server, something is listening on the port 3000. I didn't think to check what ports were actually listening. So there's no idea what is actually listening. So what is that? Netstat tech L.
UTULPN.
Tulip N or something.
Tulip
TLUMPN.
N.
Listen port UDP TCP.
So this gives us this lists everything that is listening on this box. It looks like we have over here we have SSH, which we knew about on port 22. We have our web server on port 80. That makes sense. And then we do have on port 3001 a program listening. So, for example, that might be something that a firewall might come into use, because we may not want to allow red team to talk directly to that. We may want to force them to go through this web server, which probably has security flaws in it, but we're probably going to be able to fix that and then prevent them from doing it here. So this is where a tool called UFW, Uncomplicated Firewall, I think is what it stands for. I don't know if that's actually a true description. So it looks like it is installed. UFW, and this is where I'm going to have to start, looking it up. UFW allow ports.
It's literally UFW allow.
Oh. And this is also one of those things where
UFW status, UFW enable,
Yeah.
and then UFW allow port.
if you don't know, Google. As you've noticed, I've had to ask them for TAC flags and all that stuff. If you spend time memorizing flags, it's not worth it. You can always Google it.
Man pages.
Man pages. Yeah, another example is MAN, standing for manual. UFW.
Oh,
You get a nice long list of all of the things you can do on it. It's on most of the Linux boxes you're ever going to work on, unless they're shrunk down to fit on a particular size of a system. So if you're working on an embedded thing that has a very tight limit on how much space can be stored on it, how much data can be stored on it, there might not spring for all of the manual pages, because Google them. So let's see, UFW, default, deny, incoming. They didn't like that. UFW, default, deny. Why did it not work?
Sudo?
Did I spell it wrong? Awesome.
Also sudo?
I'm root.
Oh, that'll do it.
Okay. Default incoming policy changed to deny. So what this basically means, UFW, your firewall, is just going to knock anything out that tries to come and talk to your server. This is good for most your workstations, if you're not, because you're not going to be running a website on your workstation. However, we are running a website on this server, so allow HTTP. So rules updated, and then UFW allow SSH. UFW is nice in the fact that it will take both port numbers, so for example port 80 for HTTP, or it'll take the service and it'll go with the most common thing. For example, HTTP runs on port 80. Again, if you think that I'm special because I've memorized this, I'm not. I've just used it enough. Don't spend your time memorizing it. It's so simple. Just be, you know, what port HTTP.
There's a great list on Wikipedia.
Oh, and look at there.
Port numbers.
You know, or on Wikipedia. Well, I'm maybe beating a dead horse. Don't memorize ports. Don't memorize flags. It's not worth the time or effort. So, UFW status. UFW enable, should turn it on. Status shows what's allowed. The one thing that is useful for the CDC, but would not recommend in any corporate environment type of thing, is having UFW default deny outgoing. Okay, so let's say you open your Firefox browser, you try to connect to google.com. This opens up some arbitrary high port to listen to whatever google.com sends back to you. This command will mean that you can't even open up that port and send stuff out. Not great for workstations because that prevents people from connecting out to stuff. However, no one needs to visit Google on this computer. We'll have to take that down when we want to update the machine because it has to reach out to update stuff. So we'll disable that again. However, there's a concept called a reverse shell. Has anyone ever heard of a reverse shell? A couple, not many. So the idea is there's some commands that you can run that will reach out to a remote server and ask for stuff to run, and you can basically have your computer give some IP address a shell on your system.
It's the opposite of SSH.
It's the opposite of SSH.
The client can initiate a connection to the server with SSH, but with a reverse shell, the server is been malwareified, injected with malware, whatever, and it's reaching out to a command and control server run by the attackers. So that gets around the firewall aspect of you're not accepting connections. Well, every firewall makes masquerading rules that go outbound, like Nick's talking about outbound rules. And so that's how reverse shell works.
They could disguise it as just on HTTPS. So, looking at a web browser.
They could put it on DNS.
They could put it on DNS, so that's changing your URLs into IP addresses. I haven't looked at this, so I don't actually know what's going to happen with this API. What probably will happen is there's going to be some sort of vulnerability in this that allows red team to run one command. And that would be super annoying for them if they had to run one command, reload the page, the output looks like garbage, that sort of stuff. It's going to be a big pain in the ass. So what they're probably going to do is they're going to have some sort of command that makes my server reach out to them to make a reverse shell so they can actually start to do commands on it. They get a fully interactive shell. They can hit the up arrow. They can do, change stuff, backspace. Makes their life easier. Default denying outbound requests stops them from being able to do that. Is it going to completely stop a system compromise if they get some ability to run one command? No. Is it going to make their life miserable and slow it down a ton? Yes. This competition lasts for less than 1 day. If you can make every command take 10 minutes to run, they better be really smart with which commands they run, or they're going to run out of time. Same thing in like the corporate world where they have more time. If your system could be hacked, but is a pain in the ass to hack, most people are probably going to give up and move on to a softer target. This is the you don't have to outrun the bear, you have to outrun your neighbor principle. You know, if it's just not worth their time and effort, your system is more secure because of that. Does anyone have any questions? Yes.
For signing into VMware, do you just use your Iowa State email and password?
You use your username that you gave them at iceage.org.
Okay.
And the password for that too.
And the password.
And password.
It's not domain
Yeah.
joined to Iowa State. It's open to everybody.
Yeah. All right. Do you want to talk at all about the firewalls and subnets, or I was going to go in with some other privilege isolation
I
stuff?
have paired is like set up if you want to install it and or get it on the network, and I can talk about firewalls.
Sure.
Okay.
Do you want to switch computers, or you want me to just? I mean, do you want to just use mine and I just nmap this?
Yeah, hold on. There's a couple things I can talk about.
Yeah. So this is an area that I'm not super great at, but John has a decent amount of experience with, is the idea of subnets and firewalls. Not everything on your network needs to talk to everything else. For example, the last CDC we competed in, there was a IoT security camera. If you ever hear the terms IoT, this is a security nightmare. Like if it's IoT, it's insecure, just assume that. So IoT, assumed to be insecure and broken, should not be able to talk to anything else unless absolutely necessary, and this can be done with firewalls and subnets.
Let's plug in. Let's talk about IceRink because you guys don't understand, or do you guys know like what IceRink is or what IceAge is? No idea.
I don't know.
All right, let's talk about that with
Do you
some
want
open source
to HDMI
documentation.
or?
Yeah. All right. Hopefully, I don't leak a bunch of crap because I am not prepared.
Yeah, I mean,
Can edit it out, right?
that's a trick
I
question.
got this.
All right, here we go. IceRink.
Cut out.
Version 1.1. This is from 2015, so this is old. Here's the basic diagram. And this is like a bird's eye view. It should be pretty easy to understand, right?
So this is what all of the 230, 231 labs and the CDC are run inside of.
Yes.
So this is where vulnerable machines that we can mess up on live without being harmed by the outside internet. Just to like.
Yeah, and the magic really is in the air gap and IceRink, which is what handles the packets. And I'm not by no means an expert. Nate could tell you more. But in general, it's like a mini internet. So with virtualization, you can virtualize a computer, right? So there's other pieces of network equipment that you can virtualize. Everybody knows what a switch is, right?
Yeah.
Layer 2 switch. So you can like.
don't.
Does everybody know what layer 2 and layer 3 and what the differences are? No idea. Some people know. Okay, just quickly bird's eye view. IP layer is layer 3, IP. And what do you call it? Network is layer 2. Or no, network is IP. What is what do they call it? Data link. Yeah, there you go. In ISO.
Another one of the things where memorization
Yeah.
not necessarily
Doesn't
the
really
most
matter.
useful.
But so at the IP level, you're working with IP addresses and TCP and packets. But on the data link layer, you're only working with MAC addresses. And so that's the part of the physical link, right? So a switch will know the MAC address of each leg of the switch, and there's some things you can control with that. So what we have here are virtual switches that are connecting all these networks together into IceAges like, I guess, the internet, right? But the real internet is over here, and we have what's called an air gap, which is essentially just a proxy server. So it only allows HTTP, HTTPS, and FTP. So you can apt update, you can go to istate.edu, you can go to Google, securely or non-securely, that's it. So when you pop off an Nmap scan, and you're like, or you're
Familiar with Nmap?
Yes.
Yes or no?
When you do bad network things, they don't leave the ice age. They don't get us in trouble, right? So going back to this, IP and data link, this isn't the full ISO model. You should pull it up if you're in front of your laptop, because it's a good thing to know. I don't even know it.
The OSI model.
OSI, that's the one. So another network protects, let's look at this a little closer, because that's bird's eye view. So here's what I'm talking about. Here is nitty gritty. So does this make sense to anybody?
That does not make sense to me.
What's going on here?
I don't know what that is.
So the flows are the different networks, and you have a primary vSwitch, which is the internet. So it's pretending to be the internet. When in the IP layer, you have a time to live for TCP connections. So in the internet, when I talk to Google, the TTL goes down and then reaches Google and comes back. We don't actually send things around. We just make it look like it's going through the internet. We take the packet in, decrement by some random amount the TTL, and send it back out. It ends up at its destination looking like it had gone through the internet. That's part of the whole internet scale attack generation, something. And that's where I'm talking about the vSwitches. And so now we have keyhole as well on a vSwitch through 2 keyholes and Snowbank, which is the main firewall out to the internet. So I just said firewall. What's a firewall? Anybody know? Want to give me a definition? I said this a minute ago. What layer does the firewall work on? 3.
I would guess application layer /
They can. Okay,
Yeah.
fair enough. They can work on the application layer. And it's a loaded question because they work up to, in general, they work up to, stand by. They work up to the IP layer, and sometimes, usually you do load balancers for application layer stuff. Primarily your firewall. It's your main network security device, and it works on layer 3, which is IP. So it looks like this in a diagram. And it has 2 interfaces, usually, sometimes more, often a lot more. And one side is the WAN, wide area network, and the other side is the LAN.
To be clear, though, WAN is like is what is commonly the internet.
Yes,
Most commonly.
wide area network is
But not your stuff.
to the destination. You pay your ISP for an IP on the WAN, right? When you
It's so much clearer.
when you call Comcast and you're like, hey, I need service, and they're like, okay, we'll run a cable. That's the physical link. They run the cable, and then they also give you an IP address at layer 3, and that's what you pay for. But there's only one of them, so we have routers, and then you can put all of your clients behind.
Clients, Roku TVs, Google Home.
In this case,
computers.
servers. When we're talking about CDC servers, but in the home example, your phone, your tablet, and they'll have internal addresses, and then everyone's at a different knowledge, so I don't know what to talk about.
There are
But
some things you just have to accept that you're gonna have to assume that it's true, and
Yes.
then later you'll
Right.
why
Yeah.
it's true.
so IPv6 kind of like erases this whole thing.
We'll skip IPv6.
We'll skip that.
Right now. Let's skip that.
So useful.
So, but anyway, the main idea is we were running out of IPs, and so we have these routers. They're also the backbone of the internet. Anyway, on the LAN side, this is, we'll call it a firewall now. We'll put some fire on it, because now it's not a router, it's a firewall. And we're going to put more network interfaces over here.
We got like 2 or 3 minutes left.
Anyway, the idea is, if this is, so in our example, if this is www, and this is API, well, or database or whatever, they need to talk to each other. But they only need to talk very specific things, like one port usually. So what we can do is segment the internal side of the network to prevent lateral movement. If www gets compromised, you can only talk on, say, port 3000 to the API box. You can't SSH into it. And then there's NAT rules, and maybe we'll do a whole thing on firewalls, but we're out of
We'll do the
time.
whole thing. One important thing that I'll mention is the idea of lateral movement. If you're defending, so I think of things from the attacker's perspective. If I have access to the API box, there's some critical vulnerability there, I've owned it. I now want to go from this box to this box to this box. I want to move around and get as much as possible. Segmentation and firewalls, which are a whole nother thing, prevents me from moving around. A lot of the times if you're on an internal network, you're trusted. One fun thing is like a Roku TV will let you control it if you're on the internal network, because it assumes the stuff on your internal network is trusted. So if you compromise anything on that network, you can control the Roku TV. And by segmenting the network, you remove that implicit trust. So, does anyone have questions? Did we bore anyone? Did
Probably
anyone
more than
learn?
answers.
Yeah.
I would guess. Some people
If
have
not-
fallen
If you
asleep.
think up questions, feel free to ask them in the Slack.
Yes.